All right, guys, today we're going to be learning what's called the right triangle altitude theorem, which leads to three proportions that aren't too hard to remember. And the reason it works is because when you have a right triangle and you construct an altitude from the vertex of the hypotenuse, we'll create a new point here and call it D, we've now created three similar right triangles. Let's just briefly show that these triangles are similar. So I'm going to draw three triangles here. All right triangles. And the one on the left is D is the right angle, A is the short side, and C is the long side. So there's the right angle. Then the triangle on the right is D, with C being the short side and B being the long side. So my D looks pretty bad here. Let me rewrite this triangle. So the right triangle on the right side is D for the right angle, B is the longer side, and C is the shorter side. So there is our second right triangle, and the third triangle is the big triangle itself, which has a right angle at C, and then the short side is A, and the long side is B. All right, so these are our three right triangles. We just want to show that they're all similar really quickly, and the way we're going to do that is because they share some angles. So the big angle has an A in it, and so does this little one, meaning these triangles are similar by AA, because they both share angle A, and they're both right triangles. So they have a 90-degree angle, and let's imagine that A was 30 degrees, just for an example. They both have that 30-degree angle and that 90-degree angle, therefore they are similar. We can do the same thing with angle B. Let's assume angle B was 60. That means that the second triangle has the angle 60, and the third, and the big triangle also has 60, meaning that these two triangles are similar by AA, and by the transitive property, if two of them are similar to two other ones that are similar, they're all similar. So all three of these triangles are similar. All right, so that's relevant. So now what we're going to do is we're going to label the three sides of the big triangle. We're going to be breaking up some parts, and then we're going to come up with a couple of formulas that can be useful for finding the missing sides of the right triangles and the pieces of the right triangles in this diagram. So we're going to call this side leg 1. So I'm going to call it L1 for leg 1. I'm going to call this one L2 for leg 2, and this is going to be called H1 and H2. Now that means that this is one part of the hypotenuse, and this is the second part of the hypotenuse, and these are legs. So I'm not just arbitrarily naming these are the names that they have. And we'll name the segment through the center the A, altitude. So these three segments are going to be known as mean proportionals. Leg 1 is going to be a mean proportional, meaning that you'll be able to write a proportion where leg 1 are the means, meaning the middle two terms of your proportion. And the extremes will be the parts of the hypotenuse of the two triangles that use that leg. So the two triangles that use that leg are this triangle, which has the piece of the hypotenuse H1, and the big triangle also has leg 1 in it. So we're going to be using H1 plus H2. So pretty much it is, if you're using leg 1, you write a proportion between the triangle that uses leg 1 and the other triangle that uses leg 1. So that's our first proportion we can use to find missing sides, or missing pieces of sides. The second mean proportional is going to be this one here along leg 2. So leg 2 is going to be the mean proportional, meaning those will be the middle two terms of our proportion. And then we're going to be using the two parts of the hypotenuse that use leg 2. So that would be the triangle on the right, which uses H2, and the whole triangle, which uses H1 plus H2. So that's when you use leg 1 as a mean proportional and leg 2 as a mean proportional. So that's two of our formulas we need to use. And then the last one is when we use the altitude as our mean proportional. And we use the two triangles that have that altitude in it. So the altitude is the mean proportional so the middle two terms of our proportion, and using the parts of the hypotenuse that are included in those two triangles. So the triangle on the left only uses H1, and the triangle on the right only uses H2. So let's draw a right triangle, and we're going to try and find the missing segments of that right triangle. So I'm going to draw a right triangle here. We're almost always going to draw it in this direction, but it technically doesn't need to be drawn this way. We'll call this A, B, and C, and we will say that this measurement is 3, this measurement is 4, and this measurement is 5, which is a Pythagorean triple, meaning a right triangle with these measurements does exist. And we want to find the measurement of H1, H2, and A. So firstly, I'm going to find the measure of A. We can't find the measure of A because we don't know what H1 or H2 are. So let's find the measurement of H1. So H1 uses the formula that has the mean proportional as leg 1. So leg 1 is 3. So we're going to write 3, 3, and 3 for the means. And then we're going to use H1, which is what we don't know. And we're going to use 5, which is H1 plus H2. H1 plus H2 is 5. So now if we cross multiply, we get 9 is equal to 5 times H1. We could have also called it X if that makes you feel better about it. And you could solve and get that X is equal to 9/5, which is a decimal, so we would have to round. So let's write down what X is. X is equal to, using my calculator on my phone at the moment, that's 1.8. So the measurement of H1 is 1.8, meaning we could figure out what H2 is by simply subtracting. 5 minus 1.8 should be 3.2. But let's use a mean proportional to confirm that. So if we did that, the mean proportional would use 4, which is this formula using leg 2. So we're going to use H2 here, which is, I'm going to call it Y. So I'm going to call this like X and this Y, is equal to 4 over 5, which is H1 plus H2. We'll cross multiply, get 16 is equal to 5X. We'll divide both sides by 5 and get X is equal to 16 over 5, which tells us that X is equal to, let me use my calculator, 16 divided by 5 is 3.2, which is what we said it should be. So we could have done the formula either way in this particular case. And now we're going to try and use the proportion that uses A. So we're going to write A is our mean. And we're going to plug in H1 and H2. In this case, we know that H1 is 1.8 and H2 is 3.2. And we're going to cross multiply and solve. So we're going to get A squared is equal to 1.8 times 3.2, which is 5.76. And then if I take the square root of both sides, we'll get that A is equal to 5.76 is 2.4. So the measurement of the altitude of a 3, 4, 5 right triangle is 2.4, and it divides the measurement of the hypotenuse into two segments, one measuring 1.8 and one measuring 3.2. And that's that. I'll see you guys tomorrow.